Yeah, welcome to another paper presentation on narrative visualization. This time I want to introduce a tool that's called Chart Accent Annotation for Data-Driven Storytelling. So it is about exploring the design space of annotations. Annotations involves both graphical annotations, some kinds of highlighting, graphical symbols that are integrated in a visualization, and textual annotations. Yeah, the paper was written by Donghao Ren, Matthew Bremer, Bongshin Lee, Tobias Höllerer, and Eun Kyung Ko, a team from the US, as so often. Bremer and Lee are authors that you find quite frequently in narrative visualization, so an interesting team of authors. And as always, I want to start with a teaser image that shows already the types of visualizations that are labeled. Yeah, tabular data that can be displayed in a kind of scatter plot, graph-based data that can be shown in a kind of node-link diagram, or hierarchical data that can be shown, for example, in tree maps. And these visualizations are annotated, yeah, somehow enriched with additional information that makes it easier to convey important aspects of the data. So here, for example, we have a diagram that shows life expectancy, yeah, in the highest developed country up to a bit more than 80 years, and the fertility rate. That means how many children per mother. And not too surprising, countries where the fertility rate is very high, with an average of 7 or more children, have a rather low life expectancy, with some exceptions. But on the other hand, countries where the fertility rate is quite low, so here in Hong Kong it's even below 1, I think in Singapore it's also very low, they have a higher life expectancy. And what's annotated here, Hong Kong as a kind of outlier, a particular low value, and the countries from sub-Saharan Africa. Yeah, that's not only indicated here in this kind of legend that explains how the different colors are used, but by computing a kind of hull that embeds all these countries, and that is shown as an area with a lighter color, so it's not dominant, but it clearly leads to the impression that these countries belong together, and the label is integrated here as well. In this node link diagram, we see a few nodes are labeled, actually two only, and again with a similar technique like here, a hull is computed, the corresponding area is shown, and in this case that relates or corresponds to a particular cluster in the data. Here's a tree map visualization. We see different areas like psychology, social scientists, graphic arts. And yeah, these three are emphasized. On the one hand, the color has a stronger contrast. It's not so bright like the non-emphasized areas. It has a rectangle that surrounds it with a different color than for the other rectangles, and as a final attribute it has a label. Yeah, so these are kinds of annotations. Yeah, in the introduction I want to make a few remarks on annotation in storytelling based on this paper from Ren et al. Then the design space is characterized, so the authors thought about which types of annotations exists, and then the tool Chart Accent will be briefly presented. Basically, I will show a few examples of what could be generated with this tool. You see again that there is a paper where two things are combined. On the one hand, a design space is characterized, and on the other hand, based on this characterization, a tool can be developed that makes it possible to generate visualizations, annotated visualizations of that design space. So to generate instances of this design space with a tool. Yeah, what are the contributions of this paper? First, this characterization of the design space, then the tool that can be used by others as well, and also the lessons learned from the development of this tool and from the use of this tool. And with respect to this, it's particularly important that there was an evaluation, a qualitative evaluation, that was intended to characterize how the system can be used. Yeah, as an introductory remark to annotation, I will use here this categorization from Jessica Hallmann, where she characterizes 4 layers of storytelling. The data first, yeah, data-driven storytelling, of course, requires to select an appropriate set of data. Then visual representations are chosen, for example, for tabular data, scatter plots, or for time-based data, timelines. Then interactivity is assigned. Yeah, so maybe you can zoom in or pen or filter somehow what is displayed. And then the 4th layer of storytelling, that's annotation. Yeah, so that's what we are talking about here. Annotation is characterized by Kirk as an act of adding a note or comment, or a layer of user assistance and insight. That's also a nice definition. Or adding textual or graphical elements, e.g. arrows related to some data, subset of the overall data set typically. Yeah. Kirk also described communicative intents related to annotation. So why on the heck do we want to annotate something? We may use annotation to attract the audience. Yeah. Narrative visualization is about creating engaging experiences, and annotation indeed can be useful for this. Moreover, annotations can orient the audience. That means, of course, that annotations are carefully used. They should be sparse. Yeah, with too many annotations, you create the feeling of visual clutter. Annotations clearly may help to explain. Yeah, so in particular, if more than just a label is presented, and thus facilitate interpretation. Annotation may be used to draw attention and to emphasize something. Emphasis and attracting, that's a bit related. It may help to separate and distinguish also elements. On one hand, annotations may be used to show what belongs together. We have seen annotation was used to show what belongs to a cluster. But on the same hand, on the same way, also other elements are distinguished, those that do not belong to the cluster. And it may be used for personal purposes and communication, in particular if you comment on something, so interactively are allowed to add something that may be really useful for personal purposes. That all are intents related to annotations. So annotations include labels. Maybe that's the aspect that most people would think about first when they hear about annotations. Yeah, sometimes I even have the impressions that annotation and labels is used a bit as a synonym, which is not quite correct. Trend lines is a kind of annotation to indicate a correlation. Emphasized ranges, yeah, so I always think of medical examples, think of blood values from many patients that are indicated, and then the normal range is somehow emphasized so that you immediately see whether a particular value is critically low or critically high, how often this occurs in our data set. Yeah? Shapes may be used, for example, to reveal clusters, and we have seen that clusters can have arbitrary shapes. Yeah, depends a bit on the method to create the clusters. Some methods can only create convex clusters, so then you would compute something like the convex hull in order to emphasize them. But others are more flexible and allowed to generate clusters of arbitrary shape. What is not considered to be part of an annotation? Chart titles and legends that belong to the whole visualization. Also axis and axis labels, tick marks and grid lines. Yeah, this is also not considered annotation. I think this is because these things belong to the whole visualization and not to specific types of it or specific parts of it. Yeah, everything that was described here before relates to subsets of the data. This relates to the whole data. Yeah, so that's basically what I just said. Yeah, this paper, of course, had some previous work, and it's essential to mention this because it makes the contribution clearer. There was from the same author a tool iVis Designer that provides substantial support on the one hand, yeah, which is good, but also involves a high learning effort. Bongshin Li's paper was mentioned because the role of annotation in storytelling is discussed there quite well. And specific annotation techniques are discussed in the book chapter by Stolper et al., and that is one paper that I have already introduced. There is charting software such as Excel and Tableau. There is Tableau Desktop, where you may integrate points and rectangular areas and marks, for example, in scatter plots. There is business intelligence software, but the annotation support there is quite limited. And there is the Adobe Creative Suite that's used quite frequently by illustrators if they do storytelling. That provides advanced support for annotation, but this is for manual annotation. Yeah, so there is not much which I would call high-level support. Yeah, so what are the remaining problems from this previous work, and that was addressed in this work here? A better understanding of the design space is required. So previous tools do not fully support the generation of annotations for the whole design space because the design space was not characterized. Tools are needed that are flexible on the one hand and also powerful for all types of annotation according to the design space. And also different types of data need to be considered, at least tabular data, hierarchical and time-oriented data, graph-based data, as we have seen in this node link diagram, and also map-based data. Yeah, the design space has several dimensions. I want to introduce two of them. The first is the form of annotation. Yeah, and again, I want to emphasize that textual forms of annotation, that's only one of the forms. Yeah, so for example, for one dimension, you can annotate the upper and lower bound. So this way you characterize the range. Yeah, or you can add text to describe values of a point in a scatter plot, a particular country in the examples that we have seen, for example. The other types of annotations are graphical annotations, shapes, for example. Yeah, a group of objects may be enclosed by a circle, a rectangle, or an ellipse, for example. The convex hull may be created, or alpha shapes. Yeah, that's a narrower hull than the convex hull. So that is something you see in manually created annotations quite frequently. Then there are highlights, so-called embellishments. Yeah, so you could change colors and outlines in order to annotate something. And also images may be used like glyphs or symbols. Arrows, for example, would also fall in this category. Of course, it's not necessary that you decide for one type of annotation for a particular item in the data, for example, but you could combine several of them. Then there is the second dimension, the annotation target type, and that has two, I would say, sub-dimensions, if this does not sound too unscientific. The first one is the item targets. So you may annotate single items, series of items, or sets of items. or items that fulfill a particular condition, yeah, that makes them very interesting. So, for example, the corona incidence is above 1,000, and the districts that fulfill this condition are somehow annotated and emphasized. Yeah. The second aspect of the dimension annotation target type are so-called coordinate space targets. That could be, for example, a reference value for the x-axis or the y-axis, the freezing point in a temperature diagram, or in a story about how COVID-19 has developed over time and how the incidence has changed over time. One reference value could be the starting point of vaccination. Yeah, that is definitely something that changed the further course of the pandemics, and therefore it's useful to distinguish between the course of the pandemics before vaccination and after. It could also be a span along an attribute, e.g., the duration of an interval event or the normal range of a laboratory value. Yeah, and it could be the typical descriptive statistics like mean values, median, or variance. So here you see examples, yeah, that is actually created with chart accent. So I said already, this characterization of the design space was used to design a tool that exactly allows to create instances of this design space. So here we see rather simple diagram. It shows the monthly temperatures of two cities, Chicago and Phoenix. And some of the points are labeled. So the winter temperatures in Chicago, yeah, that are clearly below the freezing points, whereas Phoenix, yeah, that is a completely different climate there. That's hot, yeah. So even in January, it's clearly be above the freezing point, the temperature. It's even above the Chicago's average temperature. So one of the reference points here is the Chicago's average temperature, 51 degrees Fahrenheit, and the freezing point of 32 degrees Fahrenheit. Yeah. So we see that some individual items are labeled, like this maximum temperature here. It's really hot in Phoenix in July. In May, it's not so hot. Here, a range is indicated, namely the springtime of the year. And here we see a rectangle that comprises a few points, and with this, yeah, a little bit helps to convey the difference in temperature in this part of the year between Phoenix and Chicago. So here's another example of visualizations created with chart accent. We see air quality related data. So that's a type of fine dust here, particularly fine dust. Beijing Air Quality Index. And it's not quite clear what the time scale here is. Maybe these are days. In any case, it's clearly visible whether the air quality was rather good, or the air pollution was light only, or it was moderate or severe. So that would mean, yeah, it's probably not good for your health to be outside for a long time if the air quality is that bad. Yeah, so that was used, by the way, from the evaluation. Yeah, so users had the task to use chart accent and to create certain visualizations based on data that was provided. Yeah, so I thought, of course, how to translate this to medicine. So, for example, there could be bar charts with laboratory values, and in a similar way, like here, you could show a normal range and the critically high or critically low values. Yeah, so that was basically my short paper presentation. To recap, the design space for annotations comprises textual and graphical annotations. We have seen that there are 4 different forms of annotations. Images and symbols was one of them. Shapes was another one, and graphic and text was the maybe most frequently used kind of annotation, which includes labels, for example. We have seen that there are different annotation target types. So on the one hand, item targets could be discriminated like single items or a series of items, and coordinate space targets like a certain range or a reference value in one of the dimensions. Yeah, some research questions that came up, at least in my mind, when I saw all this and also the related work. It's clear that there is a lot of work on information visualizations created based on certain recommendations. So in a similar way, one may think about recommendation-based medical visualization. And if I would think about applying the techniques that were presented here even more directly to medical visualization, I would think about a design space of annotations for 3D medical visualizations. Yeah, that's a bit more complex. You have problems of occlusion and so on, and the developments of guidelines and recommendations, and finally the design and development of an appropriate tool. Yeah, I want to provide some links based on the paper. So these tools were mentioned in the paper as well. They are not as powerful as Chart Accent, but they also provide at least some support. Mr. Chartpacker, Chart Builder and Data Wrapper. If you can't click on this link, you easily find these tools just by Googling for these terms. And yeah, here I created a small example myself. So I entered a little data related to some tennis players. You see Rafael Nadal and Roger Federer and Novak Djokovic, related to how often they won a Grand Slam title or were in the finals or semifinals or quarterfinals. Yeah. And I could easily create these diagrams and annotate them, and this legend was created. Yeah, you see a little bit what I adjusted here in order to create this. You also see there's a nice workflow, and at the end I could specify that I want this to be published at a website, for example. Yeah, so these are tools that you could use. That's the list of references. The paper that I presented is this one here, Ren and colleague. It was presented at the Pacific WIS Symposium in 2017. And the other papers that were used for the discussions are Jessica Hullmann's paper in TVCG, Kirk's data visualization book, I think that was a book, the paper from Lee et al. In Computer Graphics and Applications, More Than Telling a Story, Transforming Data into Visually Shared Stories. That's really one of the landmark papers on narrative visualization. This one here was a little bit, I would say, the earlier work, on which this one here was then the extension, and that was the book chapter from Charles Stolper, Bongshin Lee, and Natalie Rich and John Stasco that I have presented in one of the earlier video lectures. Yeah, with this, I want to thank you for your attention.